Hello, my name is Michael Lamb and this is Mr. Lamb's Science Corner. Last year I was involved with Starbase, which many of you may not know what Starbase is, but Starbase is a Department of Defense program at various different military bases, not all of them unfortunately, and they take fifth graders from the local area and give them a week's worth of science and math. And it's really a wonderful program. I'm not directly associated with it this year due to various circumstances, but I was asked to provide for the people who can't do Starbase, because while I'm based here in Klamath Falls, Oregon, and we're a small enough community where by running a class every week during the school year, we can get every fifth grader, public school, private school, even some kids in the homeschool. But Portland, which also has an air base, they're a much bigger community, Portland, Oregon, and they, even running 3 classes at a time, can't get even half of the students that are in fifth grade in Portland. So what do you do with the kids who can't get the fifth grade experience? Well, up till now, we've basically said, sorry, we don't have room for you. What we're going to try to do with this is to, these sets of videos, and I'm going to be making a bunch of them, is for the teachers who, for the most part, can't get into Starbase. I mean, anybody can view the YouTube, of course, but it's designed for the teachers. So what I'm trying to do is do demonstrations that a fifth grade teacher can do, and which means with as low a budget as possible, because I taught for 39 years and I know about budgets, but so the minimal budget, and we're just basically trying to get stuff that do this. So the demonstrations I'm going to show you, for the most part, are not really super fancy. They're if you're tuning to this thinking you're going to see outrageous science things or Mythbusters or whatever like this, no, because that's not the design for this. The design for this is for me to do things and to show you how to do them so you can do them yourself. Okay? So what we're going to do is we're going to start off with a really simple one, and that is a man named Bernoulli came up with a principle that basically says, if you have, and this is really good for Air Force people, if you have a wing designed like this, that if you have air flowing this way, that the air has to go in the same amount of time, it has to go a further distance over the top of the wing than it does across the bottom of the wing. And since it has to go further in the same amount of time, it has to go faster. And Bernoulli's principle says that basically the faster the particles move, the less pressure there is at right angles. So what that means is, and there's a whole lot of stuff that you could look up in the web and all like this, is that there's more air pressure pushing this way than that way. And so this provides what we call the lift for the wing. Well, there's a demonstration that we can do that basically shows the same kind of thing, and that is just a hair dryer and a ping pong ball. And I just checked, and If you have a Dollar Tree or a Dollar General or something like that there, I was just in there today, and our local store had ping pong balls, 6 of them for $1. So again, low budget. And almost everybody has some type of hairdryer at home. If not, one of your kids would. So anyway, so what we're going to do is that we're going to have air flowing around here, and so it's going to have low air pressure, and the air that's out here is going to have higher pressure. And so here's what happens. That it actually will stay put. Now, let's settle down. What I like, and always drives the kids nuts, which is a good thing, you can tilt it. You can also move it. And that freaks the kids out. And if you tilt it too far, you can go too far. So anyway, that's a quick little demonstration that you can use to describe. Again, the man's name is Bernoulli, and it works really well with Starbase because, of course, we happen to have an air base here, and so F-15 jets. What Klamath Falls does is that it provides the training for F-15 pilots. And so we train F-15 pilots, and the F-15 pilots are very proud of the fact that they have a sterling record. Not to brag a little bit about F-15 versus some of the other planes that we have, but in terms of air-to-air combat, the record is 104-0. They've managed to win 104 combats and lost 0. So pretty good. What I'm going to try to do is I'm going to try to have like 3 demonstrations at a time, and there's also going to be some math things, some math games and fun things that you can do with math, and also a few labs that one lab that I'll show you here fairly soon is the speed of sound, that you can actually take 5th graders out and measure the speed of sound. Okay, so anyway, so like I said, try to do like 3 demonstrations at a time so that you can watch something, take notes, you can go like, yeah, okay, I can get this together, and not have like, where is it? There's 30 different demonstrations on this one thing. And try and find. So I'm going to try to break it into lots of tiny little things. And I do want to apologize if I seem to go too easy, because I don't know what level of science expertise you have. Some people have lots of science expertise, some people don't. And so I'm going to assume a low level of science expertise, and if you happen to have more, please don't be offended, but then take what I'm doing and you know, go like, yeah, I can do that. And then if you're taking notes, you know, let me know if we've gone, maybe set it too high. Okay, so this one is going to be really simple. If I take bubble soap, and again, the Dollar Tree sells stuff for $1. We see that these bubbles all uniformly sink. They are heavier than air. They go down. Okay? So if I take a bowl here like this and add some baking soda, Arm & Hammer is a nice, and please realize that when I talk about different things, it's partly to help you in what you need to get. I'm not getting any money from any companies, so as is evidenced by the fact that I'm doing this in my shop, and I have a tarp as a background. So anyway, so I take some baking soda and then I take some vinegar, and this happens to be apple cider vinegar. It could be white vinegar, doesn't matter, okay? The cheaper the better. And then when I put this in here, we all know, most of us have done this before, some of you have made volcanoes, and it creates a lot of carbon dioxide. Now, carbon dioxide happens to be about half again as heavy as air. And we can see that if I set some bubbles here. Well, it worked really well when I was trying. And we can have a floating bubble. Okay, so I'll add a little more vinegar here, pump up the carbon dioxide level. Well, we saw one floating bubble. This works better. Oh, there we go, small bubble. There we have the one floating. And it eventually will go back. This works better if you happen to have an aquarium, because it tends to be a little bigger and like this. I got this because I don't have an aquarium here at home, and I went down again to the Dollar Tree and spent a whole $1 for the bowl. And let's see if I can get it bubble up some more. The last one I want to show you is going to require a little bit of work on your part. Okay. Well, okay. It was probably so. You have ethyl alcohol and the pure stuff. Okay, which maybe well, you can also use rubbing out 100% 2-propanol, which is rubbing alcohol, and I like this is a Pringles can. It's taped up. Yeah, I just put in 30 drops of the ethanol in there. I have a hole down here and shake it up. I'm hoping it's warm enough to do this, right? Otherwise, okay. And then I have here, this is a little clicker from a barbecue, and it creates electricity. And I just add a little wire to it, taped it all up, so it's nice to start. And I don't know if you'll see or not, but it creates a little spark. So I put it in the hole. Okay, so what we have here is we have 3 nice demonstrations that you can do at very low cost, and hopefully some good interest from the kids. And so what I do is I plan on doing some more. The next one that I'm going to be doing is going to be a math thing. So till we see each other again, take care.